Thank you, Stefan. Thanks for your kind introduction. Yesterday and also today we heard a lot about new vehicle architectures, new approaches, all new paradigm changes. And I wanted to think about it and the effects that this has on our tooling on Canoe. So what do I need in order to optimally test such new vehicle architectures? So my heading is New Vehicle Architectures, New Canoe, ? So let's just simply take a look. I want to begin with a small introduction, explaining why I asked this question, what are the essential characteristics that we hear about from our customers. From our perspective, I would like to elaborate on the AutoSAR adaptive platform, what's particularly decisive for us, and then I will take a look and show the impact on our Canoe. Last but not least, the colleague said one last thing is something that you have to include in your presentation, so I want to give you an outlook. With a beautiful new vehicle, whenever we take a look under the bonnet, then what are the current trends and requirements that we hear from our customers? Very clearly, ADAS, advanced driver assistance systems, camera assistance, LiDAR, and also machine learning. Connectivity, we also heard a lot about it. The vehicle possibly will be always on. It may have connections to potentially non-AutoSAR services. Thomas Beck launched that appeal to think about the back-end components, what they are going to look like, and a very decisive aspect in this connection is security, of course. Dynamic software. The new vehicle architectures allow to download software dynamically and to put it into operation, potentially during the runtime. And they also have an interface for third-party applications, which means that potentially other manufacturers could also contribute functionalities into the vehicle. And we also heard a lot about infotainment. It's a wide area. End-user devices are to be connected as easily as possible. My iPhone, my Android phone, customers have very strong demands in that regard. A nice display, good to operate, and you have to keep it up to date so that it goes together with the latest generation. I've got a very old vehicle where I still have a cassette recorder in it, and that exactly is the problem. We don't know what will be modern 10 years from now. So you have to have an opportunity for retrofitting. To put it simply, from our perspective, the new EE architectures are exactly that, smartphone on wheels, hopefully with a vector stack on it. Now, what are the key features about it? I can update it, and I can potentially also make an upgrade. I can retrofit functionality later. It may be running in the back end, but because I'm always on, it's no problem. The new function that I may be buying additionally for my vehicle can be connected very easily. All of this is possible only because it's a service-oriented architecture. Only this ensures that I can dynamically download software and put it into operation. Things like forward and backward compatibility have to be taken into consideration. The old vehicle with the new software and vice versa, that needs to be tested and safeguarded. Key enabler, that's Ethernet, and the service orientation. And of course, we are seeing that the computers in such a vehicle are much more high performance than what we know today. The data rates are really enormous. And we are going to find that the Ethernet is, of course, the important form of communication between these devices. Now let's take a more detailed look. What were the classical requirements to the vehicle? Hard real-time requirements, safety, and as cost-efficient as possible. The new requirements that we are seeing are, of course, the support of the high-performance microcontrollers, dynamic configuration, and a secure and efficient link to the cloud. For the classic requirements, there was the AUTOSAR Classic platform, and we are going to see, or as we've seen, it's rather many ECUs, 50 to 120, depending on the equipment line, with OSSEC OS on it, developed rather in C, and communication being signal-oriented. This is how Canoe was created, what it was created for. It is optimally ready for that. So the trick is that it is at compile time configured, so I know what it's going to look like in my vehicle. I've got a database, and then I can do testing. Now for the new requirements, as we've already heard, there is the AUTOSAR adaptive platform, which supports the more powerful computing nodes, typically probably less than 10 in a vehicle, with a hypervisor, POSIX OS being running there, as we've heard several times before today. The language it is developed in is C++, and the communication is service-oriented. So basically this means in the future that AUTOSAR will provide two platforms, and the data types and the description formats, they can be found in the foundation, the documents of the AUTOSAR standard. Now, what does that mean for Canoe? Today, as you can see it here, the main use case for Canoe is ECUs and networks, testing ECUs and networks. In our thoughts, we are taking the system under test, and we are pinching it in, the main access certainly being network traffic. Through a network connection, we can have access via CAN, for example, and we can thus test it all. But we also have access through measurement and test hardware, like the VT system, to stimulate the I/O pins or to test whether it behaves in the right way. Then, of course, there are other internal interfaces. Canoe, it's CAN open environment. We've got many connections. Here also third-party connections in order to really create a comprehensive, complete test environment. The main focus is, of course, on network-specific elements. The buzzword here is CAN frame. I brought a trace window. It's small print. Probably can't see it in the last rows, but as Stefan said it during the introduction, it really still is the bits and bytes. In this kind of a CAN message, I can recognize it. There are so and so many bits. It took so and so long on the bus. It was busy for so long. Nevertheless, I've got the application levels. I can open everything, and I can see wonderfully the signals, like engine data, engine speed can be seen here, or whatever your data may be there. That's wonderful, and it works well. But how is it going to work with the service orientation? Here we have to go towards the opportunity of having native service-oriented communication in the tool. Of course, this task is different from before, where we rather took network-specific elements. Buzzword here, CAN frame. And my provocative question was, do we maybe need another tool here? Of course we don't. We found a solution which we call the communication objects. We put a new layer into Canoe in order to be able to model any type of communication, especially also service-oriented. This new layer is fully integrated into the existing functionalities, the graphics window or the trace window. And it's interesting to note that mixed operation with previous buses are possible. So I can both analyze the CAN bus of a classic AUTOSAR, plus also the new proportion service-oriented. From a gateway, I can also look at it and test it. And the new vehicle architectures with a gateway, where part of it runs under classic, the other one under adaptive, so I can wonderfully combine it. So the heading here is testing the future. That's a bit blunt. What's the scenario if we're having access to future devices? Outside in our exhibition, we've got a booth where, for example, the platform for autonomous driving of NVIDIA is available locally. A micro adaptive stack is running on it with exemplary applications, all of it service-oriented. And we have direct access from Canoe. Based on the service description, we can directly install the objects, set up the objects in Canoe, and have the opportunity of accessing them. For example, we can make an analysis, a simulation of it all, or we can also perform automated testing on communication objects. Of course, you can look at that in Trace, but we can also visualize it on the panel, the calculations that the ECU makes for us. What do we think? What's still right about the Canoe approach? With regard to the new vehicles where software matters so strongly, it's not just another piece of software that's running. Of course, it has to be tested in a completely different way in our industry. Basically, of course, you want to know whether all of the production variants that you are offering to your customers, whether they are actually working. And the tests must actually be performed on the various integration developments during the development. From software component level, ECU level, subsystem level, and so on, up to the entire vehicle network level and the test drive, we need to ensure and safeguard that everything works. And Canoe can certainly be used for all that on all these levels. Now, what are the most important Canoe concepts? We can simulate and measure all networks at the same time. We've got the same time base for all these networks, and we do have a scalability on the part of Canoe, so we can distribute it on multiple PCs. Now my outlook, one last thing. We believe that software testing will of course become more and more important. That's why for next year we plan a new product, the Canoe Server. We wish to be able to run a Canoe simulation also in a server environment. So with the usual inputs, Canoe configuration, maybe a virtual system under test, and certainly with many log data of test drive or safeguard drives with tests if required. And what we have in mind is that in the server environment, you can also run third-party simulations that communicate to the Canoe server. The system under test is potentially a virtual target simulation, and it's also scalable. So if one simulation element is not enough for Canoe, we may couple up additional elements and couple them together. The result may be potentially a log file that you can analyze online, offline, and then of course test reports. For scaling it, for being able to travel or to replay the 5 million kilometers, I can of course multiply it all, and various parts of my simulation can then be run in parallel also. That was it from me. Thank you so much. We are very much interested in your feedback. I will definitely be around and available to discuss approaches with you. I already held many interesting discussions, but for the time being, thanks for the attention.